Hi, this is Bill Punch with another video in a series of videos from Michigan State University on the topic The Introduction to Computing Using Python CSE 231. We've talked about functions, we've talked about palindromes. What we're going to do today is going to write the palindrome checkers that we have written previously and put them in functions. And having done that, we'll do some fun stuff. We'll try to see which one is the fastest. Alright, let's go ahead and get started. So this is a redo on our palindrome functions. We want to check to see if a function, if a particular string is a palindrome. And one of the things that we'd like to do along the way is we'd like to measure time. And Python has a way to measure time. The way it does it is that it has a module called the time module. And inside the time module is a function called the time function. And interestingly, we can find out if we'd like some information about these modules by just in the IPython notebook putting a question behind it and evaluating. And here is the detailed information about this guy. It measures the current time in seconds since the epoch, it says. And what we need to know about that is that the epoch is some point in time in the past. And for the most part, a lot of Unix systems record the time that we used as a fixed point is January 1st, 1970 at hour 0. That's when the epoch occurred. So we measure seconds from that. So if I go ahead and go back up here and run this function, it will tell me how many seconds to 100,000th of a second have occurred since January 1st, 1970 at hour 0. We can use this information to measure how much time it takes to perform some operation. And here's an example of doing that. We're going to import both the time module and the math module, and what you'll see here is that I'm going to record the start, how many seconds starting at this point, perform some operation, and then I'm going to record the end time, and then I'm going to print out then the difference between those two values as how much time it took to perform some operation. In this particular example, we're going to use the square root operation, and we're going to have some number of iterations in a range, and we're going to just do square roots all the way through and see how long it took. Let's try that. And that's a pretty small value. When you're using those smaller values, you feel like it's kind of inaccurate. And so what we're going to do is let's pump up the number of iterations. So that was 100. Let's do 1,000,000. Sure, that makes sense. So to do 1,000,000 calls, a square root took about 0.37 seconds. And if we do it again, you'll see that we'll get a slightly different number every time that we do it. And that's because the operating system is running, different things are going on, and so it gives us a good idea. 0.36 seconds is about how long it took to do 1,000,000 iterations of square root. What we'd like to do is apply that then to some palindrome functions and see how well they work. It's clear that we need to do a lot of something, 1,000,000 calls of square root, to get any sort of significant time value. So we're going to have that problem now with our palindromes. We need really long strings of palindromes if we're going to get any reasonable sort of measurement. And here's how we're going to make artificially construct some really big palindromes. We're going to generate a big string, and we'll do that by making multiple copies of a particular string, string.ascii letters, all the upper and lowercase letters together. We're going to make a reverse copy of that string and concatenate them together. So if we look at string.ascii.letters. Here are all the letters in the alphabet from lowercase a to capital Z. And we're going to write a little function that takes advantage of that, and it's going to be called make palindrome. We're going to take in some multiplier, and what we're going to do is we're going to use string multiplication, which is replication. We're going to take string.ascii letters and multiply it by the factor that we pass in, make 50 copies, make 100 copies, whatever we pass in. We're then going to take that string once we made it, and we're going to use Python's standard string reverser guy, make a back string, and then we're going to put the front string concatenated with the back string, and that will be a really big palindrome. And so let's take a look at that. Let's do it for a very small number, like 2, and let's print the palindrome to see what it looks like. First, let's define the function. Then let's go ahead and run it. And so here's the string that it generated. So I asked for 2 copies of the big string, which goes all the way out to right here. Right, so 2 copies out to this point, and then here's 2 copies again, only I reversed the string, which means that this thing is going to be a palindrome. Well, 2's not enough, so we need to do much better than that. If I do that, I don't really want to print it out. So I know I've been playing with this. Let's make one that's 500. That's a big one. Let's do that. If I do that, then how long is that? 52,000 characters in the string that I know is a palindrome. That'll be a great challenge. Please take a look at the video that follows this one, and I'll show you how you can use this timing information to measure which one of the many palindrome approaches that we've covered would be most efficient. In particular, we'll show you how to implement those palindromes as functions.